Hello friends, welcome you in my YouTube channel. I am Dr. Mohammad Sirajul Akfazi, Assistant Professor, Department of Chemistry, Meles College, Muzaffarpur. So today in this video, I am going to talk about biomolecules. You know, biomolecules is important chapters in 12th. So what actually is the syllabus of biomolecules? So first, carbohydrates. You know, the carbohydrates are primarily produced by plants and form a very large group of naturally occurring organic compounds. So general formula and the most important compound is glucose. So classification of carbohydrate: monosaccharide, oligosaccharide and polysaccharides. Monosaccharide, a carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde or ketone is called a monosaccharide. Oligosaccharide, carbohydrate that yield 2 to 10 monosaccharide units on hydrolysis are called oligosaccharides. And polysaccharide, carbohydrate which yield a large number of monosaccharide units on hydrolysis are called polysaccharides. Monosaccharide: triose, tetrose, pentose, hexose and heptose. General term. So aldehyde: aldotetriose, aldotetrose, aldopentose, aldohexose, aldoheptose. And ketones: ketotetriose, ketotetrose, ketopentose, ketohexose, ketoheptose. So preparation of glucose. How glucose prepares? So from sucrose hydrolysis you will get the glucose and fructose. Starch. Commercially, glucose is obtained by hydrolysis of starch by boiling it with dilute sulfuric acid at 393 Kelvin under pressure. So starch or cellulose give the glucose. Same way, structure of glucose. You see, its molecular formula was found to be C6H12O6. On prolonged preheating with HI, it forms N-hexose. This is N-hexose, suggesting that all 6 carbon atoms are linked in a state chain. So there are 6 carbon and all carbon attached in the ring form. The second important point: glucose reacts with hydroxylamine to form an oxime and add a molecule of hydrogen cyanide to give cyanohydride. These reactions confirm the presence of carbonyl groups. You see, this is the glucose. It reacts with hydroxylamine forming oximes, and this reacts with HCN forming cyanohydride, which is the characteristic reaction of aldehyde. Glucose gets oxidized to 6-carbon carboxylic acid, gluconic acid, on reactions with mild oxidizing agent like bromine water, and this indicates that carbonyl group is present as aldehyde group. So this is linked to bromine water forming gluconic acid. Acetylation of glucose with acetic anhydride gives glucose pentacetate, which confirms the presence of 5-OH group. Since it exists as a stable compound, 5-OH groups should be attached to different carbon atoms. So look at here, because it reacts with acetic anhydride and replacement of all OH with the acetyl-CoH. On oxidation with nitric acid, glucose as well as gluconic acid both yield a dicarboxylic acid, saccharide and saccharic acid, and this indicates the presence of a primary alcohol group in glucose. So look at here, this is the glucose react with oxidation give the acid, saccharic acid, and here also gluconic acid give the same. The exact spatial arrangement of different OH group was given by Fischer after studying many other properties. Its configuration is correctly represented as 1, and this is. So gluconic acid is represented as 2nd and saccharic acid as 3rd. This is the representation. So glucose is correctly named as positive glucose D before the name of glucose represent the configurations where positive represent dextrorotative nature of the molecule. It should be remembered that D and L have no relations with the optical activity of the compound. They are also not related to letter D and L. The meaning D and L notation is as follows. The letter D or L before the name of any compound indicates the relative configuration of particular stereoisomer of compound with respect to configurations of some other compound. Configurations of which is known. In the case of carbohydrate, this refers to their relations with the particular isomers of glyceraldehyde. Glyceraldehyde contains one asymmetric carbon atom and exit into enantiomer form as shown below. This is glyceraldehyde and this is also glyceraldehyde. Only the position of OH group is different. So here you see D positive glyceraldehyde and D plus glucose. So cyclic structure of glucose. Despite having an aldehyde group, glucose does not give shift stage, does not form the hydrogen sulfide addition product with sodium bisulfite. The pentaacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO group. Glucose is found in existing two different crystalline forms, which are named as alpha and beta. The alpha form of glucose is obtained by the crystallization from concentrated solution of glucose, while the beta form is obtained by crystallization from hot saturated liquid solutions. This behavior could not be explained by the open chain structure. For glucose, it was proposed that one of the OH group may add to the CHO group and form a cyclic hemiacetal structure. It was found that glucose forms 6-member ring in which OH at carbon 5 is involved in the ring formations. So look at here, this is the fifth, and there is no aldehyde groups. So this is alpha D glucose and this is beta D glucose. This OH group is involved in alpha. So pyrene-like structure, so we call it pyranose structure and furanose structure. So alpha D glucopyranose and beta D glucopyranose. This is the alpha positions. So this is alpha and this is the beta. In fructose, fructose is important ketohexose. It is obtained along with the glucose by hydrolysis of disaccharide sucrose. It is a natural monosaccharide found in fruits, honey and vegetable. It is pure form. It is used as a sweetener. It is also important ketohexose. So structure of fructose, you see purine. So furanose structure, alpha D fructofuranose and beta D fructofuranose. So this is the position, alpha position, this is the beta position and 5-member ring. Now disaccharide, you have already read that disaccharide on hydrolysis beta allotrophic acid or enzyme will two molecules are either the same or different monosaccharide. The two monosaccharides are joined together by oxide linkage formed by the loss of water molecules. So look at here, sucrose gives D-glucose and D-fructose. Now you see how it is attached, D-fructose and D-glucose. Alpha D-glucose here and this is beta D-fructose. This is the structure of sucrose. Maltose, you know, it is also associated with the glycosidic linkage, alpha D-glucose and this is alpha D-glucose. Lactose, you know, this is beta D-glucose and beta D-glucose. This is the attachments. So these are the disaccharides. Now polysaccharide means you have the example starch. Starch is main storage polysaccharide of plant. It is most important dietary source for human being. High content of starch is found in cereals, roots, tubes, some vegetables in polymers of alpha glucose and consist of two components, amylose and amylopectin. Amylose is water soluble component which constitute about 15 to 20% of the starch. Chemically, amylose is long and unbranched chain with 200 to 1000 alpha D positive glucose unit held together by C1 and C4 glycosidic linkage. Amylopectin is insoluble in water and constitute about 80 to 85% starch. Is branch chain polymers alpha D glucose unit in which chain is formed by the carbon 1,4 glycosidic linkage, where branching occurs by carbon 1 to carbon 6 glycosidic linkage. Look at here, this is 1 and this is the 4 alpha linkage, this is 1 and 4 alpha linkage, and so on. And this is amylopectin, you see alpha linkage and branching and branching. And cellulose occurs exclusively in plants and is the most abundant organic substance in plant kingdom. It is predominant constituent of the cell wall of the plant cell. Cellulose is the straight chains, you see here attachments alpha linkage. Glycogen. The carbohydrates are stored in animal body as glycogen. It is also known as animal starch because its structure is similar to the amylopectin and in rather more highly branched. It is present in liver, muscles and brain. When the body needs glucose, enzymes break the glucose down to glucose. Glucose is also found in yeast and fungi. So, importance of carbohydrate. Carbohydrates are essential for life in both plants and animals. They form a major portions of our food. Honey has been used for a long time as an instant source of energy whereas in Ayurvedic system of medicine, carbohydrates are used as a storage molecules as a starch in plants and glycogen in animals. Cell wall of the bacteria and plant is made up of cellulose. We build furniture etc. from cellulose in the form of wood and clothes ourselves with the cellulose in the form of cotton fiber. They provide raw material for many important industries like textiles, paper, liquors and beverages. So friends, hope this video will be helpful to you. If you like this video, then subscribe my channel and thanks for watching.